the given figure, a hinged construction is pictured. It consists of two rods with a length 2L. One of the rod's tip is fixed to a moving point A, and the other rod's tip C moves with a constant velocity v along direction which passes the point A at the distance L. Find the acceleration of the connection point B of the rods during the moment when the distance between the points A and C is 2L. Let's consider our triangle of rods. All its sides are equal to 2L and the angles are 60 degrees, since the triangle is equilateral. Now, let's consider the triangle formed by the velocity v, the side L, and the base of the larger triangle. Since the base of the triangle is twice the length of the leg, the angle opposite this leg is 30 degrees. Thus, the angle between the velocity v and the rod is 30 degrees. Now, let's think about the velocity of point B. At first glance, it might seem arbitrary, but this is not the case. We also know that the velocity of point B must be directed at 90 degrees angle to the rod AB. Why? Because the rod AB rotates around point A, and the velocity of point B must be perpendicular to the rod AB. By the inextensibility condition, the projection of the velocity point B onto the rod must also be equal to the x. We know that the angle between the rods is 60 degrees. This means that the angle between the velocity u and its projection on the rod is angle of 30 degrees. Now let's draw velocity triangle corresponding to this condition. From it we can find the velocity of point B. And we can see that the velocity of point B is equal to the velocity of point C. And these velocities are parallel since they form the same angles with the rod. Now let's determine the acceleration of point B. We know that the acceleration of point C is 0 as point C moves at constant velocity. Let's switch to the reference frame associated with point C. In this frame, the velocity of point C is 0 and the velocity of point B is also 0, since their velocities in the ground frame are parallel and equal in magnitude. If the velocity of point B in the reference frame of point C is 0, then its normal acceleration in this frame is also 0. This means that the only acceleration point B can have in the reference frame of point C is the tangential acceleration directed perpendicular to the rod AB. Now let's return to the ground frame. We know that the acceleration of point C is 0. Therefore, the acceleration of point B in the ground frame will be equal to the tangential acceleration in the reference frame of point C. However, we also know that the rod AB rotates around point A and point B moves along a circular path. This means that point B has a normal acceleration directed along the rod AB. Let's depict the total acceleration of point B. It must be perpendicular to the rod AB, as we proved earlier. Consider the acceleration triangle. The angle between the normal and total acceleration is 30 degrees. Then the total acceleration can be expressed as the total acceleration is equal to normal acceleration divided by cosine of 30 degrees. The normal acceleration of point B is equal to velocity squared divided by 2L, where 2L is the length of the rod AB. Thus, the total acceleration of point B is equal to square of speed divided by length and by square root of 3. If you enjoyed this video, don't forget to like and subscribe to my channel to see more videos like this. You can also join my Telegram channel where I post interesting problems and full solutions to the problems from my videos.